Hello everyone, this is G. Chandana, graduating from Srinivasa Ramanujan Institute of Technology, and my holding roll number is 234018045. Today my topic is maclaurin series from the subject linear algebraic and the calculus. Before going to the maclaurin series expansion, we have to know about the Taylor series expansion of f of x about x is equals to 0. Here is the formula of the Taylor series, that is f of x is equals to f of a plus x minus a into f dash of a plus x minus a whole square by 2 factorial into f double dash of a plus x minus a whole cube by 3 factorial into f triple dash of a and plus so on plus x minus a whole power of n by n factorial into f power of n into a plus and so on. Let us consider this equation as equation 1. And next, if we put a is equals to 0 in the equation 1, we get the maclaurin series of expansion of f of x about x is equals to 0. So if we put a is equals to 0 in the first equation, we get this equation f of x is equals to f of 0 plus x into f dash of 0 plus x square by 2 factorial into f double dash of 0 plus and so on plus x power n by n factorial into f of n of 0 plus and so on. Here we can see the maclaurin's theorem. If f of 0 comma x is the real such that f power of n minus 1 is continuous on closed interval of 0 comma x, if f of n minus 1 is derivable on open interval of 0 comma x and p belongs to real number, then there exists a real number theta belongs to 0 comma 1 such that f of x is equals to f of 0 plus x into f dash of 0 plus x square by 2 factorial into f double dash of 0 plus and so on x power n minus 1 by n minus 1 factorial into f power of n minus 1 into x plus x power of n into 1 minus theta whole power of n minus p by p into n minus 1 factorial into p power of n into theta x. Along that maclaurin's expansion, we also use these formulas, that is d by dx of log x is equals to 1 by x, d by dx of u by v is equals to v into d by dx of u minus u into d by dx of v by v square, and d by dx of x square is equals to 2x, and also we use e power x is equals to 1 and log 2 is equals to 0. Next we are going to the problem. This is a question to solve. Show that log of 1 plus e power of x is equals to log 2 plus x by 2 plus x square by 8 plus x power 4 by 192 plus and so on. From this equation we have to deduce that into e power x by e power of x plus 1 is equals to 1 by 2 plus x by 4 minus x power of 3 by 4 power of 8 plus and so on. So first we have to write the given f of x, that is log of 1 plus e power of x by using the maclaurin's theorem. This is a formula of the maclaurin's theorem, that is f of x is equals to f of 0 plus x into f dash of 0 plus x square by 2 factorial into f double dash of 0 and plus so on. So we will consider this equation as equation 1. And next we have f of x is equals to log 1 plus e power of x. If we substitute 0 in this f of x, we get this solution, that is f of 0 is equals to log of 1 plus e power of 0. We know e power of 0 is equals to 1, that is log of 1 plus 1. From this that is equals to log 2. If we differentiate f of x, that is f dash of x is equals to, here we use log x formula, that is d by dx of log x is equals to 1 by x. So in place of x, here we have 1 plus e power of x. So we write 1 by 1 plus e power of x, and also we have to differentiate e power of x. d by dx of e power of x is also e power of x. So that is equals to e power of x by 1 plus e power of x. If we substitute a 0 in the x, that is f dash of 0 is equals to e power of 0 by 1 plus e power of 0. That is equals to 1 by 1 plus 2, that is 1 by 1 plus 1, that is equals to 1 by 2. If we differentiate f dash of x, we will get f double dash of x. That is, here also we use d by dx of u by v formula, that is u is equals to e power of x and v is equals to 1 plus e power of x. If we differentiate this, we get this, that is f double dash of x is equals to e power of x by 1 plus e power of x whole square. If we substitute 0 in this in this f double dash of x, we'll get 1 plus e power of 0 into e power of 0 minus e power of 0 by 1 plus e power of 0 whole square. Here e power of 0 is equals to 1. Now we substitute e power of 0 is equals to 1 in this. So we'll get 2 minus 1 is by 4, that is 1 by 4. So like this we'll calculate f of x, f dash of x, f double dash of x. Then we will do f triple dash of x. Same formula we use here also, that is d by dx of u by v. Finally we get e power of x into 1 minus e power of x by 1 plus e power of x whole cube. If we substitute 0 in the x, so we'll get let's substitute e power of 0 into 1 plus e power of 0 by 1 plus e power of 0 whole cube. Finally here 1 minus 1 is equals to 0, so whole becomes 0. If we differentiate f triple dash of x, we will get this equation. If we substitute 0 in this, we will get minus 1 by 8. We have to substitute. If we substitute all the calculated values in the equation 1, that is log of 1 plus e power of x is equals to log 2 plus x into 1 by 2 plus x square by 2 factorial into 1 by 4 plus x cube into 0 plus x power 4 by 4 factorial into minus 1 by 8. If we solve this, we get this equation, that is log of 1 plus e power of x is equals to log 2 plus x by 2 plus x square by 8 minus x power 4 by 192 plus and so on. We consider this equation as equation 2. If we differentiate this equation 2 with respect to x, there also we use log x, d by dx of log x, that is 1 by e power of x into e power of x. And here we will get log 2 is equals to 0 and d by dx of x is equals to 1. So 0 plus 1 by 2 plus x square, d by dx of x square is equals to 2x and d by dx of x power 4 is equals to 4 into x cube. So finally we get the equation e power of x by 1 plus e power of x is equals to 1 by 2 plus x by 4 minus x cube by 4 power 8 plus and so on. This is the equation we have to deduce from the first equation. So hence proved. Thank you for watching this.